Hi everybody, it's Al again. Have a quick update on what we're doing here. Just going to show you how the system automatically transfers to power, to standby power from a commercial power failure. Tomorrow my electrician is coming in. He's an electrician helper because my son is no longer with us. He's in El Paso, so need somebody to kind of help me out with getting all the wiring done. We're going to wire the entire shed all the way around, put some lights up there, kind of like these lights are here, and rewire all that. And then we're going to put the original transfer panel that we took out right there, that 6 circuit, and we're going to mount that outside so it's easy to transfer. There's just a few circuits left on that panel out there, so those are going to go on this panel here, and then we'll have everything set up. And that box here is going to go on my 12-volt battery bank there with a 12-volt inverter that you see there, and then that 240 T240 transformer. So right now, let's take a look at this. This is sensing commercial power. So things are good. It's float charging because my batteries are full. I look over here, and from my solar, hang on, let me switch this. From my solar, I have 84 volts coming in. It's leaving, it's 27.6. So there's 0.8 amp, 0.9 amps coming in, 1 amp, and then about 2.8 amps leaving to the batteries. Today I've generated 3.5 kilowatts, and I'll show you why. But right now it's floating, so really there's nothing going on. Because this circuit here, or this MagnaSine inverter, is sensing commercial power. It's sensing commercial power. It's on float charge, and I'm going to show you what we're going to do here. The transfer panel, the usefulness of having this MagnaSine inverter the way it's set up in this panel is that I can leave this all the time set up so it is on generator power. As long as the MagnaSine inverter senses commercial power, it will actually just act like a bypass, bring the power here, and feeds the house. You can see here, there is power going into the house, and power being consumed by, laptops and the refrigerator and, those kind of things. And it's actually pretty well balanced out, I might add. So we did a good job of balancing the circuits. But so everything, all the breakers are on, as you can see, right? The switches are all set to generator instead of line, and I keep them there. So right now everything is running off commercial power. As you saw, the charger or the MagnaSine inverter is charging, which means it's monitoring the batteries, and I have actually a battery monitoring kit that I have to add to it, and that will sense the temperature of the batteries, and it will adjust properly. But I don't really rely on the MagnaSine to charge the batteries as much as I rely on my charge controller. That out-of-back charge controller is just an animal. It just works beautifully. It has absolute beautiful logic to get this stuff done and get the batteries in shape. So right now all the breakers are on in here, and this circuit here, this 30 amp circuit, is the one that feeds the MagnaSine inverter. So right now the MagnaSine knows that the commercial power is available. So if I simulate a commercial power failure, right, and we go inside, the power already transferred. I mean, it transfers in milliseconds. I don't even see it at the house. The only reason I can tell something transferred is because I hear a beep from the power supply on my computers. I have a battery backup system, so it just monitors that out. So look now, instead of charging, now it says it's inverting, and it's inverting 18 amps. So it's 18 amps and 28 volts, give or take, and that's what we're pulling out. If we look at this now, this no longer says 2.8 amps. Now it's climbed up to 20 amps, and the reason for that is because I'm drawing from the battery power to invert it with my battery, with my inverter. My solar panels are being tasked by the charge controller to go ahead and feed power to my batteries so they can get charged up. So those batteries down there are the ones that are being used right now to power the inverter, who right now is inverting power to the house and is sending 12 amps to the house, right? And we have 14.7 amps here. So let's do a test. My pump just came on, and it's on a different circuit. That's the next circuit that we got to put in the house, or we got to put it in the shed, and you'll see how that is affected. So we saw what the readings were over there, about 12 amps or so. We see that, you know, this is fairly low. So let's go ahead and turn on a few things here and see what happens. So we're gonna come over here. We're gonna turn some lights on. Let me see. We're gonna add a couple minutes to that, and I'm gonna turn on some lights. So I turned on the lights here. So we have lights, and we have a microwave going. So, and as you see, I've not done anything. I've not tripped any breakers. I've not moved anything around. Let's take a look at what's going on here. So the kitchen is on this circuit here. So we're drawing about 2 kilowatts of power here, and very little here, about 100 somewhat watts, maybe a couple hundred watts. But there's 2 kilowatts being drawn here. If I had the TV on and stuff like that, then we'll be drawn off this side, and most of the bedrooms are over here. So that microwave and the lights actually suck quite a bit of juice. So the solar panels should be sensing that right now, and should be adjusting for that load. Or not the solar panels, but the charge controller. So as you can see, the charge controller now is shooting out 63 amps to the batteries to charge them. It's no longer 12. And we're now inverting 92 amps. So this is all fully automatic. All I have to do is walk out of the house. If I leave my switches in the oh, and by the way, so these 63 amps is equivalent to 1.64 kilowatts. This is being fed by 2 kilowatts of solar panels, so I can go even higher. I have another 350 watts or so spare capacity on that 2 kilowatt array. Plus the house is still using that the power from the 1.6 kilowatts of solar that I have with my other panels. And if we look at the meter here, this meter here ought to be moving back at a pretty good clip. So this is how the system works. It's fully automatic. As long as I keep this breaker off, it senses that there's a loss of commercial power from the street, and I don't have to do anything at all other than just leave the breakers, or the selector switches I should say, in my generator transfer panel to generator. And I know that my inverter has a built-in automatic transfer switch and a sensing circuit that it will monitor or will sense the loss of power and will automatically transfer the power to it. So right now the microwave is off. This came down to about 500 watts or so. That's because the lights are on. If I go turn the lights off, that should drop even further, back to where it used to be. And then if we go take a look at the circuit or the meter, we should see that the meter is still running backwards at a pretty good clip. So the lights are off. We go back over there. We'll take a look at how much power we're drawing from the generator control transfer panel. We see it's back to normal right here, right? And then we go back over here to the shed, and things probably are, for the most part, stabilized by now, because we reduced the power workload on it. So this thing now, you can see the fan is on, or you can hear the fan is on. It's dropped down to 22. It'll continue charging the batteries. It's putting out 600 watts now instead of the 1.64 kilowatts that it was a few minutes ago. This is inverting and it's no longer inverting 90 amps, but it's inverting 12 amps. So fully automatic system, MagnaSine rules. I'm sure Outbacks are just as good. I looked at the specifications of both. I like MagnaSine better, so I went for it. It's real simple to stack. It's a lot more. They're a little more expensive than Outback, but you save money in the long term because of the intelligence and the design of the MagnaSine. They put a port in here, which is the stacking port, which is this one in red. And what that allows you to do is allows you to have a communications cable like this here that goes to the remote panel. And you can add, for example, this MagnaSine inverter is 4 kilowatts. Well, it'll go up to 8 kilowatts for about 5 minutes, and it can go to 3,000 watts for like 30 minutes to make up for excessive loads that are temporary, right? But if that's not enough, I can go to 8 kilowatts or I can go to 12 kilowatts by just simply adding another MagnaSine inverter, stacking it by using this port right here. So this port will have a cable that will go to the next MagnaSine inverter's stacking port like this. Actually, there's only 2 that you can stack, I'm sorry. And then that'll give you an 8 kilowatt design. So it's a pretty cool deal. It's really nice the way that they set it up. I really can't complain. I do have a few other things that I need to add to it. That was the box for the remote control panel. Here's the box for the, as you can see, is the Magnum Energy, the MagnaSine. This is the battery monitor kit that I have to get installed here. But the system has turned out to be, everything that I expected it to do. In milliseconds, it transfers power back and forth. I don't have to worry about it. I save tons of electricity. As you can see, this is going back down to now about 14 amps. It's floating already, so the batteries are topped off at 27.6 volts. And if I go outside and take a look at my power meter, it should still be running at a pretty good clip going backwards. So you can see it is moving pretty good. Now let me show you something else that I did in the original design that it's paying out really good. So right now I'm not using a whole lot of power, right? Because the TVs are not on, we're not cooking, we're not doing a whole lot of stuff that we could be doing. So if you remember in some of my previous videos, I put this switch, this selector switch here that I can choose from my grid tie inverters to my, to turning them off to MagnaSine. Well, there's a third position that I can go. And here's my 2 inverters for right now. Of course, all this is going to get cleaned up this weekend, hopefully. I can turn this to this here, to this position. Now, my MagnaSine inverter is powered still. And now, my inverters here are getting powered on. I don't know why this one has a fault right now. Let's see if I can get this to... this one's not working all that good right now. Something in it is not right, but this one is inverting. So there's about 240 watts, 250 watts coming out of that one right now. I'll have to take a look at this one later. That is life with those junk Chinese inverters. I hate those things. It's just a complete waste of money. So I'm gonna get a better inverter, throw it on there. But you'll be able to see that this thing should be moving at a faster clip because we added more load. If that other one was running, the other inverter would be adding about 650 watts to this here, and it should be moving faster. But right now I'm happy with the meter going backwards. We're selling power to the power company, and I am on top of that consuming my own power. So I really can't ask for anything better than that. Life is good. We hope to be done wiring this building this weekend, putting the other transfer panel in place, connecting that to that system, and then I'll work on these inverters here, clean that up, and do a better design there. What I may do is actually tap off of those from the power coming in directly from the 80 volts coming from the solar power. So that's it for the update. God bless everybody. thank the Lord for everything that He does for you, for all the blessings you have, good or bad, because there are bad blessings, because He wants to keep you away from trouble, steer you away from danger. Sometimes we think that, hey, you know, we're not getting our way. Maybe we're having a little hard time with something, and that's because He's not letting us do something that we shouldn't be doing, or fall into something that we shouldn't fall into. So there's always a good reason why the Lord does something for His people, for the people that He is going to call sons of God later on. So anyways, God bless everybody. Take care. Keep the faith. And we'll talk to you later.